Hi everybody, this is the review video for solving systems of equations test. Okay, so on problem 1 of your review, they give you the equations of two lines and they want the x value of the solution of the system. So, because I don't ask you to solve using substitution or elimination or graphing, it's okay to go ahead and use your calculator in this problem. That would be the quickest method. So on your calculator, you would go to the home screen, you'd hit new document, and if they ask you to save, you say no, and you add a calculator. You go to Menu, Algebra, Solve Systems of Linear Equations. Now we have two equations, and the variables are x and y. So we hit OK, and now we're going to enter in the equations just like we see them. So it's 2x plus y equals 12. And the other equation, the second equation, is negative x minus 3y equals negative 11. And you hit enter. And if you notice, the first variable was x, so our x value is 5. And that's all that they're asking for. They only want the x value, so you could put x equals 5 there. All right, on problem 2, it's the same type of problem, but instead of the x value, they want the y value. They give you two equations, and they want the y value of the solution. Okay, so we go to our calculator, and we type in the equations just like we see them in the problem. We go Menu, Algebra, Solve Systems of Linear Equations. We have two equations, and their variables are x and y, so we hit OK. And we type in 2x plus y equals 5. And in the second equation, we're going to type in y equals x minus 4 and hit enter. So our y value, the second variable we defined, is negative 1 in this case. So y equals negative 1. Okay, problem 3, it says if the solutions of the system below was z negative 4, what value of c would complete the system? Prove your answer. So we need to figure out what value of z would complete the system. So z is really our x value and negative 4 is our y value. So what I'm going to do is I'm going to write the first equation, negative 5x plus 4y equals 9. And I'm going to plug in z for x because z is our x value. So negative 5 times z plus 4y equals, and what am I replacing with y? Negative 4. My y value is negative 4. So 4 times negative 4 equals 9. Okay, negative 5 times z is negative 5z. 4 times negative 4 is negative 16 equals 9. I'm going to add 16 to both sides, and you get negative 5z left on that side, and 9 plus 16 is 25. Divide both sides by negative 5, and z comes out to equal negative 5. 25 divided by negative 5 is negative 5. So now we have to prove your answer. So we're going to take the second equation, x minus 4y equals 11, and we're going to try, remember our x value is z, so z minus 4, and our y value is negative 4 equals 11. And we're going to check and place in the z value that we found of negative 5 to see if this comes out to be a true statement. So we plugged in negative 5 for z. Negative 4 times negative 4 is positive 16 equals 11. And negative 5 plus 16 becomes 11. And 11 does equal 11, so z equals negative 5 is the correct answer. Okay, number 4 says create a solution or create an equation that would make the system have no solutions. No solutions means parallel lines. Parallel lines have no intersection points because they never intersect, therefore there is no solution. So parallel lines have the same slope, and in our equation the slope is negative 2 in the equation given, so the equation we come up with also has to have a slope of negative 2. So I can write y equals 2x, and the only thing we have to be careful of here is if we add a +2 or any number, that's okay. The only thing we cannot do is make it the exact same equation. Because if it's the exact same equation, then that's another circumstance. That means they're the same line. That will not make them parallel. So parallel lines are two different lines that have the same slope. So anything y equals 2x plus anything except for -5 would work here. All right, number 5 says create an equation that would make the system have infinitely many solutions. Infinitely many means that those are coinciding lines. The two equations must be coinciding lines, because coinciding lines are the same lines. They lie on top of one another. So for example, if I had this graph of a line, the coinciding line would be the same graph that lies right on top of it. Okay, because they're intersecting all the time, they have infinitely many solutions. Alrighty, so y equals 2x minus 5 would be the correct answer here, because if they're the same line, they have the same equation. Coinciding lines have infinitely many solutions, and parallel lines have no solutions. That's really important for you to remember. Okay, number 6 says Tamara has 12 dimes and 5 quarters on her table. If the cost comes out to be $2.25, how many dimes and how many quarters does she have? So we're looking for how many dimes and quarters. So I'm going to define my variables. Q equals the number of quarters, and D equals the number of dimes. And she has a total of 12 dimes and quarters. So the number of quarters plus the number of dimes has to equal 12. And the cost of the total cost that she has of money is going to be $2.25. So when we have a quarter, it's worth 25 cents. So 25 cents times the amount of quarters we have gives you the amount of money we have in quarters. Dimes, on the other hand, are 10 cents. So if we multiply the number of dimes by 10 cents, then we'll have the amount of money we have in dimes. When you add those two amounts together, it should come out to equal her total amount of $2.25. Okay, so now we can just go into our calculator. Since I don't ask you to use elimination or substitution or graphing, you can do whatever you want. And the quickest way is to go into the calculator. So we go into our calculator, we hit Menu, Algebra, Solve Systems and Linear Equations. And our equations are we have 2 of them, but our variables this time are not x and y. They are d and q. So I'm going to put d as my first variable and q as my second. And I separate them by a comma. I hit OK, and then I type in my equations. D plus q equals 12. Okay, and the second equation is 0.1d plus 0.25q equals 2.25. Hit enter. So if d was the first variable I defined, we have 5 dimes. D is 5 and q is 7. So we have 5 dimes and 7 quarters. So the number of dimes is 5 and the number of quarters is 7. All right, let's move on to 7. The perimeter of a rectangular swimming pool is 44 yards. If the length of the rectangle is 4 more yards than the width, what are the dimensions of the pool? So we're looking for the dimensions, which are the length and width. So L is equal to length and W is equal to width. So we also have to remember that the perimeter of a rectangle is equal to 2 times the length plus 2 times the width, which makes sense because 2 sides of the rectangle make up the length and 2 sides make up the width, and when you add up the sides, that gives you the perimeter. So that's going to be our first equation. 2 times the length plus 2 times the width equals, it tells us the perimeter is 44 yards. All right, and then the length, it says, is 4 more I'm sorry, the length of the rectangle is 4 more yards than the width. So the length equals W plus 4, the width plus 4. All right? In this problem, once again, I have not told you to use substitution or elimination. You are more than welcome to do that, but I prefer using the calculator. I feel like it's a quicker method of solving this problem. So I'm going to go here. I'm going to hit Menu, Algebra. Oh, sorry about that. I'm going to hit Menu, Algebra, Solve Systems of Linear Equations. We have two equations here, and our variables are L and W. I hit OK. My first equation is 2L plus 2W equals 44. And then it says that the length L is equal to the width plus 4. Hit enter. And it tells you that the length, the first variable, is 13 yards, and the width is 9 yards. So we need to go back to our worksheet and fill that in. Length is 13 yards, and width is 9 yards. All right, if you doubled the length, what would the perimeter be? So 2 times the length is equal to 2 times 13, which is equal to 26. So our new length is 26 yards. And we need to find the perimeter now. So remember, perimeter formula is 2 times the length plus 2 times the width. And if our length now is 26, we plug in 26 where we see length. And our width is 9, so 2 times 9. 2 times 26 is 42. Oh, I'm sorry, not 42, 52. Plus 2 times 9 is 18. And 52 plus 18 is 70. So the new perimeter, if you doubled the length, would be 70 yards. All right, on number 8, we're going to write a system of equations that represents the following table. We're given x value, and this is your x values for both equations. These are going to be your y values for the first equation you come up with, and these are going to be the y value for the second equation you come up with. And the way I'm doing this is if we're given a table like this and you have to come up with 2 equations, I go to the calculator. Okay, so I go to the calculator, I hit the home screen, I go to New Document, I don't save, and I go to Add List in Spreadsheets. Okay, up at the top, my A box should have an X, and my B box should have a Y. Okay, when I type this in, I type in my X values, which are 2, 4, 6, and 8. Now, looking at my worksheet, I'm going to go ahead and focus on this set of X and Y values for my first equation. So, my first set of Y values is 0, 10, 20, and 30. Alright, now once I've done that, I go to Menu, Statistics, Stat Calculations, and Linear Regression, MX plus B. I have to tell my calculator what I want my X list to be labeled and what I want my Y list to be labeled. So my X list is going to be X, and my Y list is going to be Y. After I've defined those, I hit OK. And if you notice, they give us our M and B value. So M is 5 and B is 10. So if my first equation I'm coming up with needs to be in Y equals mx plus b form, remember my M value was 5, so Y equals 5x, and my B value was negative 10, so minus 10. So that is my first equation, Y equals 5x minus 10. Okay, now the second equation I come up with needs to involve the X values and then the Y values. So I'm going to go to my calculator, and the X values stay the same, but my Y values are what's changing. So I just type over my old ones, 14, 20, 26, and 32. And if you notice, it automatically changes my m and b values. So my m value here is 3 and my b value is 8. So I'm going to write y equals mx plus b. And my m value is 3, so y equals 3x, and my b value is 8, so plus 8. So my second equation is y equals 3x plus 8. And we have now found a system of equations to represent the following table. Okay, on 9, we're given a graph, and we need to find the solution. If you notice, when you're given a graph and you have two lines graphed, what you have to find is the intersection of those two lines. So I need to extend these two lines, and you have to be careful and make sure that your slope remains the same. So here I went over 1, down 3, so I'm going to go over 1, down 3 again. Oh wait, nope. I went over 1, down 4. I'm sorry. Over 1, down 4. So I need to go over 1, down 4. And there's my point. The next point of that line that I can connect. Now in this case, in this line, I go down to over 3. So I'm going to go down to over 3. And I extend this line. And if you notice, they intersect at that point. So that is the solution to this system. So it's at -3, -9. I know this is down off the graph, but it's -9. So my x value is -3, and my y value is -9. All right. Now, at number 10, they're asking us to use the substitution method. So what I need to do is see if there's a variable by itself, and there is. It's y, and y is equal to 2x minus 30. So I'm going to plug 2x minus 30 into the second equation and replace that with y. Or sorry, replace y with 2x minus 30. So I write my second equation, and instead of writing y this time, I'm going to write 2x minus 30. So I write x plus 2x minus 30 equals 90. Now I combine like terms, and I get 3x minus 30 equals 90. I add 30 on both sides, and I get 3x equals 120. Divide by 3, and you get x equals 40. Now that we know what our x value is, we take that and plug it back into one of the original equations. So we can use y equals 2x minus 30, or y equals 2 times 40 minus 30. So y equals 80 minus 30, and y equals 50. So my solution is 40, 50. And we write our solution as an ordered pair. Okay, on problem 11, they want us to solve by elimination. So using elimination, we have to get a zero pair with one of our variables. And it's important that our x's are on top of our x's and our y's are on top of our y's, which they are, so our terms are aligned. And now I'm going to choose to eliminate my x values. If you choose to eliminate your y values, that's completely okay too. So I want a zero pair with my x values. So in order to create a zero pair, this top x value needs to be positive 4. And to make that positive 4, I would multiply this by 2. And since I can't just multiply part of an equation by 2, I have to multiply the whole thing by 2. So I'm going to multiply this whole thing by 2. And I get 4x plus 2y equals 6. Now I didn't multiply my bottom equation by anything, so I'm going to bring that down. That becomes a zero pair. And 2 minus 4y is negative 2y equals negative 6. Then I divide both sides by negative 2, and y equals 3. So now that I found my y value, I take it and plug it back into one of the other equations. So negative 4x minus 4y equals negative 12. And I'm going to replace y with 3. So negative 4x minus 4 times 3 equals negative 12. Negative 4x minus 12 equals minus 12. So I add 12 to both sides. That cancels out, and I'm left with negative 4x equals 0. Divide by negative 4. So x equals 0 divided by negative 4, and 0 divided by anything is just 0. So my solution is 0, 3. All right, the last couple of problems. It says explain why a system would have no solution, and what would the graph look like? It would be, a system would have no solution if no lines, sorry, not if no lines, if the system contains lines that do not intersect. And lines that do not intersect are parallel. These would be parallel lines. Okay, in the second problem it says explain why a system would have all real or infinitely many solutions. What would the graph look like? If the lines were always intersecting, the system would have infinitely many solutions. Okay, and the lines that are always intersecting are coinciding lines. So these would be coinciding lines. Or in other words, the same line. Okay, coinciding lines have infinitely many solutions, and they're the same equation, same line. Parallel lines have no solution because they never intersect. Okay, explain why a system would have only one solution, and what would the graph look like? This would be if the lines are neither parallel or perpendicular, or parallel or coinciding. So, if they are not parallel or not coinciding and they're linear, it's a system of linear equations, it will have one solution because lines will only intersect at one point. Okay, I'll be available tomorrow morning at 6:45 if you have any last minute questions. I hope this was helpful, and I hope y'all are studying really hard for your test and you get a good night's rest. See y'all tomorrow.